everyone. Today we're going to be doing factoring, obviously. This is based entirely on the factoring that we were doing in the previous lesson, but it is a shortcut that you will occasionally get to see. So if I have something like, let's say x squared minus, and this is how I wrote this problem, you should recognize this 0. It may have caused you a little bit of a kerfuffle in the most recent assignment. X squared minus 0x, we're going to say minus 16. We're just going to factor this. We're going to factor it exactly like we did yesterday, okay? So x squared minus 0x minus 16. We know that the first thing that we need to do is stare at this 16 and figure out the different factors. Remember, we count our way up. 1, 2, 3 isn't going to do us any good. 4 is just going to give us another 4, so we know that we're done. And what we say now, and what we need to do now, is which of these 3 pairs is going to give me that 0? Okay? For those of you that are more astute, we need 4 and 4. 4 minus 4 is 0. So, let's go ahead and do that. So we'll have our x's like we've had. And then I need 4 minus 4. So that's a positive 4 minus 4. And we should notice here that what we have is called a difference of squares. We're going to add and subtract the exact same value. And this is a shortcut that is going to work as long as this term is a perfect square and this term is a perfect square. Now what I mean by a perfect square is that it has a square root, that is a whole number or a whole variable or something like that. So on this side, as long as it's 16, which is 4 times 4, or maybe 9, which is 3 times 3, or 25, which is 5 times 5, or 100, which is 10 times 10. Those will all work over on this side, because they're all perfect squares. If I had like a 25, then it would be plus or minus 5. Okay? X squared. We can also have like an x to the 4th, because then it would just be x squared times x squared. We could have an x to the... Actually, just about any even one is going to work here. Right? Of course, right. Yeah, pretty much any even exponent here is going to work, because it'll just be x to the 4th, x to the 4th. But the important thing to note here, and we'll cover the more complicated cases for leading coefficients tomorrow in the next lesson, but we could also have a perfect square right here, like a 25, or the 100, or the 9, or a 36, or a 64, or an 81. Those are all perfect squares that have a whole number of square roots. Okay? So let me give you an example. And typically, we're not actually going to bother writing that minus 0x, but it may help you to think about it as having that minus 0x. So let's take a look at, let's do 36 x to the 4th minus 81. Okay? Now, we didn't bother to write the minus 0x, but it's the same thing. We're going to have our perfect square set up like this. The square root of 81 is 9. It'll be plus or minus. X to the 4th means we need an x squared on both sides. And then this 36, the perfect square root of 6, is 6. And then we're done. Okay? We had the perfect difference of squares. Now, sometimes this 6 won't be here, and it'll just have an x squared minus 9, and you'll notice you could go again and break that up even further. In fact, let me go check the homework really quick. Sorry, because I'm not going to pause the video, and I'm going to make you watch all of this, which is dull and boring for you. So, sorry. Okay, yep, you don't need that quite yet. You'll need it eventually, but you're not going to need it for homework that's associated with this. So that's difference of squares. It's a special case where you're still pretty much using the same skill we had yesterday, but is actually faster and easier than what we're doing, because you just need to find the square roots. let me help you really quick. This is my last thing. This is, again, a time where you may want to get out a piece of paper and take some notes here. Another thing that you may want to do is just do like perfect squares, because that'll help you. So I'm just going to make a list of some of the ones that I'm going to use, the most common, most often. 2 squared, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, I think 13 squared is 169, but at that point I'm starting to run out of ones that I've got memorized and just know off the top of my head. So this is something that you may want to take a moment and just kind of make a list of these, because these are the ones that you're going to see the most frequently. And I think that is exactly as far as I want to go with this stuff. So this should get posted. I'm recording this on Friday. So this should get posted on Tuesday, Monday or Tuesday. Reminder that there was an assessment after the second lesson, so make sure that you're getting that done. If you're this far, you should be definitely able to do all those things. And we're coming up on the next assessment, which is, we've got a slightly more complicated version of this stuff. And factoring, we'll be doing kind of the greatest common factor to get something out and then make it easier to factor once we've factored once. Okay? And then we're going to start messing with leading coefficients. So we're a little ways away from that yet. And I would like to spend as much time on factoring as y'all need. So if you still need more practice, more time, Soup's open to that. Otherwise, I'll see all of you in class. And again, as always, please, and I know this is factoring stuff, if you need any help, jump to my Google Meet, and I will see you then.